and welcome to Model Kit Stuff. So in this episode we're actually going to get to grips with the model for the first time, and we're going to do that in the sequence of the instructions. So as many of you know who've been following my channel for a while, I don't usually build model ships in the sequence that the instructions lay out, but actually in the case of this one the instruction layout is not too bad, but to help those of you who are building along following the instruction sequence just seems a little bit more sensible in this case. So we'll be starting at step 1, which means we'll be looking at the engine pods first. So there's 4 engine pods. They would all be slightly different, and Stephen will tell you a little bit more about those later on. So the parts for these 4 engine pods are spread across several sprues, so you do have to hunt them out a little bit. But in step 1, that pod we can find on the K sprue. So we need part 24 and part 23. So what I'm going to do is I'm going to remove all of these parts and we'll put them, all the loose parts together in their sort of build sequence, if you like, so that we can build each pod up and keep them separate, ready for fitting, because there may well be some differences. On the real ship, 2 of them are fixed and 2 of them are movable. Right, now we've removed them from the sprue, we're just going to trim the gate nubs off and get it down to a point where we can just sand it. Now there's 4 parts to these, the 4th one being the propeller, and I'm going to put that on separately at the end after these are painted up and detailed up. Just because the propellers are stainless steel, which is something that was done differently than the usual bronze, and we will get Stephen to explain that to you in a moment. So before we glue the 2 halves together, we have this shaft, which I've just sanded so it's nice and smooth, got the nubs off, and that places inside. And when you put your propeller on, that should be able to rotate. So we'll put the second half together like so. It's easier to glue the shaft in if you want to not have the propeller rotating. I want to see if we can get this to rotate, so there we go. So I'm going to run some extra thin liquid poly cement into the seam. And we're just going to clamp that together. And then if we run some into this seam here, that should be enough, and we'll put a peg on that. There we go. So that's the first shaft together. I'll build up the other 3 engine nacelles and then get back to you. Okay, so the glue is dried on this pod now, and it spins, so we know that the propeller shaft in the pod is good and rotating. So the next thing we need to do is just get these nubs sanded down and the rough seam sanded down. So we're going to start with a medium coarse grit sanding stick and just shape it. Now when we're shaping into a curve, my preference is to work from the bottom of the curve in. I find that if you work like that, top down, that you can put a flat on if you're not careful. So it's a better way of maintaining the shape. And you just have to be careful at this end here. There is a little lump, and that is supposed to be there, but it does look like a gate nub. So Now in some areas it's a little tricky to get in with the sanding stick, so what we can do is scrape the seam away. So you can use a knife to just carefully scrape the seam flat, flush with where it needs to be, or you can use a seam removing tool like I'm going to do, which just gets in there and takes that seam back to where you want it. So we've completed the cleanup of the pods. You can see here the two different types. This one has a steeper little fitting here for going into the hull, so you can't really mix them up. So now they're cleaned up, we're ready for priming, and anything red on the ship I'm going to be priming in pink. So while we wait for the second coat of paint to dry on the engine nacelles, let's hand you over to Stephen, who's going to tell you a little bit more about them.
Hello, Stephen Payne here, Naval Architect of Queen Mary 2. Now I'm often asked, why did we employ 4 podded propulsion units rather than conventional propellers on shaft lines? Well, Carnival Corporation, they spearheaded the development of podded propulsion with the first 2 passenger ships to use pods, the Elation and the Paradise. And there was a series of 8 fantasy class ships, 6 of which had shaft lines and the last 2 had the podded drive. And we were able to assess the efficiency gains from comparing those last 2 ships with the first 6 ones. And we found out that there was about a 9% improvement in propulsive efficiency, which meant lower fuel costs and the like. So when it came to designing Queen Mary 2, I thought pods would be the natural choice. And you really have to understand how a propeller works to understand why pods are so much more efficient, because the propeller throws off the thrust as it turns at an angle, and so part of the thrust is being used to push the ship forward, and part of it, because it's being done at an offset angle, is actually trying to turn the ship. So obviously there's a wastage there, and that's why on twin screw ships the propellers turn in opposite directions to try and cancel out that sideways thrust. Now the other thing with shaft lines is that they have to be angled in order to connect up with the engine or the electric motor inside the ship. And they also have to be splayed out so that when the power actually reaches the propeller, you've got a combination of things that aren't optimal, because what you'd really like is to have the shaft lines parallel to the center line, but in effect they're splayed out and they're also at this funny angle in order for the shaft to connect with the motor. And then on top of that, you've got the inherent inefficiency of the propeller throwing off the thrust at an angle. Now, a propulsion pod, where you have an electric motor inside a casing hanging underneath the ship, that totally negates all those inefficiencies, because you can orientate the pod into the best slipstream or water flow to give you the best propulsive performance. On top of that, by mounting the propeller in front of the pod rather than behind, the propeller is experiencing undisturbed water as it moves through the water. And that means that as the propeller rotates, it's less likely to experience differences in water flow from the top and the bottom, which leads to noise and vibration. So not only are podded ships more efficient than their shaft line equivalent, but they're also quieter and have less vibration. So Queen Mary 2 has 4 pods. They're actually mermaid pods. Rolls-Royce and Alstom clubbed together and they form the Mermaid Consortium, and that's what we have on Queen Mary 2. Each pod has a power of 21.5 megawatts. So we have 86 megawatts in total for the propulsion power, and that can drive the ship up to about 29.5 knots at full power. Now for me, the most amazing thing about these 4 pods is that each one, with its attendant equipment inside the ship, weighs something in the order of 320 tons. And 320 tons is the weight of a 747 jumbo jet, fully fueled, full of passengers, as it takes off. So in effect, we've got 4 jumbo jets hanging at the aft end of Queen Mary 2. Now the forward pair of pods on Queen Mary 2, all they do are drive the ship forwards or backwards, so they're not steerable. But the aft pair are totally azimuthing, and the power into the electric motor from the ship is transmitted through slip rings, so there are no cables that get tangled if the pods rotate round 360 degrees, so it's all done through slip rings, and this is some absolutely amazing technology. And the 4 pods are faithfully reproduced on the Revell model, and the only addition that the real life pods have are zinc strips in order to provide some protection from corrosion.
So we have our engine nacelles painted, and you could leave them like that and they would look perfectly good. Mounted under the ship with a propeller on, they'll look fine. However, I'm going to try and add the zinc strips, which are the anti-rusting anodes. And there's around about 30 of these on each engine pod, so 120 of them to be made. And what I've got here is one that I have made, and it is out of 0.1 millimeter thick microstrip by 0.5 of a millimeter, and it is 2.5 millimeters long. And that for me is working out around about right for the length and diameter. They're actually a bit chunkier than you imagine when you look at them, but I think that is about right. So we're going to make a load of these up, and then we're going to stick them on some masking tape and paint them up, and then we're going to attempt to glue them on. So a simple way to cut these anodes to length is to stick them on some masking tape along the edge of a ruler, which means as I'm doing 2.5, I can do the halfway point of every half centimetre. So it's nice and easy to cut them to length. Okay, so that should give us 20, so we've not quite got enough for the first pod. Once they've been cut to length, what I'm doing is taking them off the masking tape and transferring them to this frisket film, which is much lower tack than masking tape, but has enough tack to hold them in place while we paint them. So it's a clear film, so it's a little bit difficult for you to see the film, but that's basically just been taped down. And then once these are all moved over, we can use the tape that's stuck to this ruler to paint some more, and you can see to cut some more, and you can see those are stuck on now. we can paint them in the silver that we want to paint them, and then when we come to remove them, we get much less resistance than we would do if we were taking them off the masking tape. As you can see, the risk of taking them off masking tape once they're painted is that we could make the paint crack, whereas it will not have any resistance really taking it off the frisket tape, frisket film I should say, so we should be okay. So that's our anodes cut out, 30 per pod, and some spares just in case. So what we'll do next is we'll put a gloss black primer on them, and then when that's dried we'll spray them silver, and then we can attach them straight onto the engine pods. Okay, so we're now at the point where we need to put these anodes on. So they have been painted gloss black, and then we have spray painted them in the same silver that we're going to be using for the propellers. So now we need to stick them on, and the easiest way of doing that is to actually use some varnish. There's no weight to these, so we just need something tacky to hold them in place. When the varnish dries, they should stay on, but then we're going to varnish over it anyway, and that hopefully will be enough. I'm going to have to apologise for the bottle. The bottle's in shot just to keep the camera focused on the pod here, because as soon as I take that away, the autofocus goes back to the cutting mat and this becomes blurry. So what I have done is I've decanted a small amount of varnish into a bottle top, and we will put a little bit of varnish on the area that we want to put the anodes on, and then we will work from there. And then out of shot I have a reference picture that I'm using for placing the anodes. So anodes are sacrificial, and as such they get replaced every couple of years. So we're just going to put a little bit of varnish down. And placing these first two will just help with the running line along the body, I think. Okay, so you get the basic idea. I'm going to carry on and get this finished, and then I'll come back to you when it's done. So while the paint is drying on my engine pods, we can get to grips with one of the repetitive tasks that needs to be tackled. Now on this model there is 14 lifeboats
and 8 tenders. So we can be cleaning up parts in between other jobs, just to get us ahead for when we need them. So the lifeboats come in 2 halves, but there is quite a lot of detail to be captured on them. It's a bit difficult to see with it being white plastic, but there's a number of windows to be painted on. The canvas cover is a slightly different colour, and these do mate together using location points. So you can see there's actually some careful cleanup needed of the nubs, because on the hull of this, the connection nub goes right up to this ridge, which is actually the rubber bumper. So we're going to tackle that first, and the way to tackle that is to at first sand the nub down, or cut the nub down flush with this rubbing bar. So I'm just going in with my side cutters, and then I'm going to just flatten that down. We have to be really careful not to take any material off this bar. We're just leveling it down. And now we've got that flush, I'm going to use a very sharp knife, and I'm using the base of the knife, not the point, but the heel of the knife, and just gently rocking the knife blade over that tab, putting on a bit of pressure, so that what we're actually doing is cutting down through that lump of plastic down to the hull. So as long as you do it slowly, then you're keeping control of it. And then we're going to go in underneath the bottom of it, keeping our blade against the hull, and slowly rock the blade up to that bumper. There we go, and that has taken most of the material out, so we can then go in. You'll notice that the end of my emery board is modified, so I've got a thin strip. We can then go in with that thin strip, putting my finger on top of it to put a little bit of pressure down, and just clean up anything that may still be there and not quite even, and make sure everything's nice and flush. And you can even go in with your knife and just scrape the edge to make sure everything's nice and flat if you feel there's a need to. There we go, so that is how we remove the nubs and tidy up that one. Now on the upper half of the lifeboat, again there is 2 nubs. Oops. One on each side, and they're actually on these flexible openings, and when you look at pictures these tend to fade a little bit, so we will be painting these slightly differently. So we've trimmed that down as much as we can, and then we just want to get that flat so there's no witness of the connecting gate from the sprue. once you've cleaned up your parts, you can put them to one side, ready for painting at a later date once they've all been done.
So that is my zinc sacrificial anodes done on my 4 engine nacelles. Once they'd been stuck on, as you'd seen with the varnish, they were given brush coated the whole engine pod with varnish just to seal it all in. I will give it another coat of varnish through the airbrush to level things off, but actually the varnish does a good job of levelling anyway, so you don't get much in the way of brush strokes. Now I do have some leftovers, and I cut extras in case I flicked a few out of my tweezers, which happened 3 or 4 times. So I think I've used about 4 out of my row of extras. But don't, if you've done that, don't throw them away, because you need some of these for underneath the hull and the stern area as well. So I will keep hold of those. So that's it done. We'll put the propellers on them at a later stage when they get fitted to the hull after the hull has been prepped and painted.
So now these pods are built up, we need to store them away somewhere nice and safe until we're ready to use them, which will be after we've painted the hull. So want to keep the dust off them, stop them bumping into things and possibly knocking off those zinc strips, so they're safe for another day. At the same time as we are painting the bow thrusters, we do have the option of painting the main propellers at the same time, because we're going to do those in the same steel colour. Now it's up to you whether you put them on at this stage in the build onto the engine pods, or whether you put them on at the back end. It all depends on how you're going to be handling your model during the build. But you can certainly paint them at the same time as you paint the bow thrusters, and then put them to one side if you're not putting them on until later on in the build. So to clean up the propellers, you want to remove the sprue gate as close as you can to the blade, but leaving enough that you don't damage the blade when you remove it. Then we're going to go in and just sand and shape it, and I find a flat emery board is a good way of at least starting that process. So I like to do the to shape the blade back and do the edge with a flat, because it's easier than with like a sanding sponge. It's much easier to deform the shape with a sanding sponge. There isn't much to clean up on these, fortunately. So there's 2 connection sprues, 2 connection nubs that we need to remove. And then there is a mould seam which goes from the base of this blade up to the forward edge of that blade, and that carries on all the way through. Now you can do what I'm going to do and use a seam scraper to just get in there, because it's quite a small space, and scrape it back into shape. If you've not got a seam scraper, then a sharp number 11 blade will do just as well. A sharp number 11 blade will do just as well, and just get in there and remove any seam line. It's worth taking your time to get this right, because as soon as you put some paint on it, the seam line will be very visible, and actually it's quite a thick seam line. So the other thing that you probably want to do is take your blade nice and flat and just take it down to the cone along the blade edge, and make sure that you've got no flash or anything sticking up from the blade, so that it all looks, well, as it would be on the ship. Now, just out of interest, all of these blades actually have a hole in them, which is for lifting rig. And if you look at the ones that are spare on the deck, you'll see little holes in them. But those holes get plugged once the propeller blade is mounted underwater for use. Okay, so we have to do that for all 4 gaps on all 4 propellers. So it's a little time consuming, but it's absolutely worth getting done right.
Queen Mary 2's propellers are manufactured from stainless steel rather than the normal nickel, aluminium, bronze. And the reason for this is that I was very conscious that with Queen Mary 2's high speed and high power requirement, that the propellers were required to maintain their efficiency as much as possible. Now, the traditional nickel, aluminium, bronze material that most ships' propellers are manufactured from, very, very quickly the surface finish of those propellers deteriorates. And over time, they could lose about up to 15% of their propulsive efficiency. And the way that that's dealt with is that periodically divers go down and polish the blades underwater. Well, I didn't want that for Queen Mary 2. I wanted her to have really good, efficient propellers continuously. So the solution was to use stainless steel. That at the time, fortunately, was about the equivalent price for the nickel, aluminium, bronze. And so Queen Mary 2 has 4 stainless steel propellers. Each propeller is made up of 4 blades, and these are bolted onto the hub, and we carry 8 spare blades on the forecastle, 2 blades for each of the 4 propellers should there be a damage and we need to replace 1 or 2 of the blades.
So there are a number of areas on this build where we have some fairly repetitive work to be done. We've got quite a few lifeboats that we need to build up, and we have an awful lot of rooms that we need to prepare. Now, we'll be putting this in relatively early in the build. This is the internal rooms that go behind the lower balconies inside the ship's hull. So this goes in before we put the main deck in place. So whilst you're waiting for the next video, one of the things you can be doing is some of this repetitive work. So this needs cleaning up, and we need to put carpet in it. The flooring will be quite visible once it's inside the hull. So all of this needs to be painted in. And I'm going to show you a quick method of doing that, which should speed up what is quite a laborious task. And then you guys can get on with that while you wait for the next video. So what you're going to need for this, and we will look at this a little bit more closely when I come to do mine, but what you need to do with this is paint this white initially on the inside, or if you prefer, just spray it with a matte dull coat, and that will be sufficient, as this is going inside the hull, to take the shine off the plastic and make it look non-plastic like. Then what we have to do is paint the floors, and a quick solution for that Each one of these rooms is 5mm, so a quick solution for that is to get some masking tape that is 5mm wide. And here we go. Run some strips and then paint the masking tape the colour of the floor. Now I'm using this Humbrol matte middle stone, which is number 225. You could also use the Vallejo 71.031 for this task. So once you've painted your strips of masking tape, then what you're simply going to do is lift your masking tape up, feed it into your room, press it down with your tweezers and make sure that it's in place okay, and then either with a knife or a pair of shears just trim that down. You're going to need to make sure that that remains flush, because this is the mating edge with the kit, and that'll leave us with a carpet behind. So that is the solution I'm going to be using. Obviously you can go in there with a paintbrush and very carefully paint it if you wish, but this is a sort of job that you can pick up while paint's drying and various other things are happening, and just rattle off 20 or so rooms at a time.
So that's us done for this video. The engine pods have been completed. We just need to finish off the propellers, which we'll do when we look at doing the bow thrusters. We'll also have a look at the stabilisers, making some paint masks ready for painting the hull, and then start the clean-up and preparation of the hull. So I hope you'll be able to join Stephen and myself for that. We look forward to seeing you. In the meantime, take care everyone, and we will see you very soon.